day everyone, this is Group 1 and I am Aliyah Anastasia. Today's lesson, we are going to discuss about Quarter 3, Week 1, Module 1. It is about permutation of objects and these are the following objectives of this lesson. First, for us to be able to use the fundamental counting principle to calculate the number of outcomes. Second, use factorial notation to express the number of outcomes. Third, evaluate expressions involving factorials to compute the number of outcomes. Lastly, use factorial notation to express the number of permutation of n elements taken R at a time. Now, let us begin discussing our first objective. Let us start with the counting outcomes. The term counting is the fundamental concept of mathematics, and when we say counting outcomes, it means to say that the number of results of what we count on a given situation. And there are 4 standard ways to count all the outcomes of a given situation. Number 1 is by systematically writing all the possibilities. Next is by drawing a tree diagram pointing out all the different possible paths for the outcomes. Next is by using fundamental counting principle, or it can be by the use of permutation and combination techniques. Now, let us talk about fundamental counting principle. So what is fundamental counting principle? And how do we use this principle of counting? Fundamental counting principle is also known as multiplication principle. It is a guiding rule that can be used to determine the total number of ways or possible outcomes different events or situations can occur by simply multiplying the total possible outcomes for each individual event. So if event M has M possible outcomes and event N has N possible outcomes, then event M followed by event N has M times N possible ways. Sa madaling salita, the fundamental counting principle states that if there are M ways to do one thing and N ways to do another thing, then there are M times N ways to do both things. Remind ko lang na hindi ito limited sa dalawang event lang, maaaring more than 2. Let us have an example number 1. The problem is for main dish. You can choose steak or chickens. Your side dish can be rice or potatoes, and your drink can be tea or water. Determine the number of possible meals if you just have one of each. Okay, so for this, let us apply directly the fundamental counting principle by multiplying the different events given in a problem. For the first event, we have the main dish. So we have 2 choices. It's either steak or chicken. Second event is the side dish, and we have 2 choices. It's either rice or potatoes. Next is third event. We have 2 choices, tea or water. Then multiply these 3 events. 2 times 2 times 2 is equal to the total number of possible outcomes of 8 possible meals. Now, we can justify our answer by using a tree diagram. This is another way to count outcomes. Pag sinabing tree diagram, magdodraw tayo ng trunks o sanga na magre-represent ng mga possible meals na pwede nating makreate. So, umpisahan natin sa main dish. It's either steak or chicken. Gawa tayo ng combo meals. Let's say, ang gusto kong kainin ay steak na ang side dish na gusto ko ay rice at ang kasamang drinks ay tea. So, isang possible meal na yon. Ang pangalawang possible meal can be steak, potatoes, and tea. Pangatlo, steak, rice, pero this time, ang gusto ko naman drinks ay water. Another possible meal is steak, potatoes, and water. Now, dito naman tayo sa chicken. Ano-ano ang mga possible meal na pwede natin magawa sa chicken? So, ulitin natin. Chicken, rice, and tea. Ito ang palimang possible meal natin na ang main dish ay chicken. Pang-anim na possible meal ay chicken, potatoes, and tea. Pang-pito, chicken, rice, and water. At ang pang-walo na possible meal ay chicken, potatoes, and water. Meron tayong 8 possible meals, so tama ang paggamit ng fundamental counting principle na kung saan minultiply natin ang given choices sa bawat event. Subukan natin muli. Let us have example number 2. The problem is a sandwich can be made with 3 different types of bread, 5 different meats, and 2 types of cheese. How many types of sandwiches can be made if each sandwich consists of 1 bread, 1 meat, and 1 cheese? To solve this, let us apply again the fundamental counting principle, or FCP for short. We will just multiply the 3 events. For the first event, we have 3 breads. For the second event, we have 5 meats. And for the third event, we have 2 cheese. Multiply these 3 events. 3 times 5 times 2 is equal to 30 possible types of sandwiches. And this is the tree diagram of the problem. To more understand the FCP, or Fundamental Counting Principle, Christian will share a few more examples with us.
O naman Aliyah, pero isa lang to kasi may tuturo din ako sa kanila. Okay, let's have another example. For a college interview, Kenneth has to choose what to wear from the following: 4 slacks, 3 shirts, 2 shoes, and 5 ties. How many possible outfits does he have to choose from? So dito, kailangan lang natin i-multiply yung 4 things na na-mention kanina to determine the number of outfits na posible niyang masuot sa college interview. Para makuha natin ang final answer, i-multiply lang natin sila sa isa't isa. So, 4 times 3 equals 12. 12 times 2 equals 24. 24 times 5 equals 120. So, ang total outfits na pwede niyang masuot sa interview ay 120. Let's move on to the next one. My locker combination is 23, 5, and 17. Does it matter what order I turn the numbers? Well, another set of numbers in a different order will not open your locker. Why? Because 23, 5, 17 is different from 23, 17, and 5, or any other set of these 3 numbers. So to open your locker, the order of the number combination does matter. This arrangement is called permutation. But what is permutation? Permutation is an arrangement of distinct objects in which order is important. The permutation notations used here are P quantity NR is equal to NPR. To find the number of permutations of n distinct objects, we can either use the permutation formula or the fundamental counting principle. There are 2 types of permutation: permutations with repetitions. The formula used here is P quantity NR is equal to n raised to r. Repetitions are allowed: n times n times n times n times n r times. Permutations without repetition. A. This include all n objects and get reduced each time. The formula used here is P quantity nn is equal to n factorial. B. Arranging fewer than all the objects. Formula: permutation of n objects taken r at a time. The permutation of n things or ways taken r at a time that is equal to the n factorial all over the quantity nr factorial. Let's have an example. Permutation with repetitions. Formula: P quantity nr is equal to n raised to r. Example number 1. How many permutations with repetition allowed when we are making a 3-letter permutation from a set with 5 elements A, B, C, D, and E? Given, ang n natin ay equal to 5 at ang r naman natin ay equal to 3. So, paano nga ba nakuha yon? Ang n ay ang total number ng pagpipilian mo, samantalang r naman ay ang total number ng pipiliin mo. Ang gagawin natin dito ay 3-letter permutation. Sa first letter, meron tayong 5 choices na pwedeng pagpilian. So, sa first letter, 5 posibleng mailagay dito, which are yung A, B, C, D, or E. At since repetition is allowed, sa second letter ay ganun din. Pwede ulit maulit yung kahit anong letter na nabanggit. Ganun din sa third letter. Kaya ang total number ng possible choices sa kanilang tatlo ay 5. Kung by formula nyo siya isusulat, ganito magiging itsura niya. P quantity nr is equal to n raised to r equals 5 raised to 3 equals 125 permutations. Kung by fundamental principle counting naman, imbis na 5 raised to 3 Isusulat nyo mismo yung limang 5 at ipagmumultiply. So, 5 times 5 times 5 equals 125 permutation. Joshua, di ba nandiyan yung detailed answer ng problem na to?
Oo, Christian. Ito ang detailed answer ng problem mo kanina. As we can see, there are 3 permutations that repeat a letter, kagaya nitong AAA at CCE. There are also permutation na no repeated letters like EDC at DAE. At kung bibilangin natin ang lahat ng ito, we can have 125 permutations. Another problem is a lock has a 5-digit code. Each code is chosen from 0 to 9 and a digit can be repeated. How many different codes can you have? So n is equals to 10 because our given ranges from 0 to 9. R is equals 5 naman dahil ang lalagyan natin ng code ay nangangailangan lang ng 5 digits. For the first digit, we have 10 possible choices. Pwede tayong mamili from 0 to 9. Sa second digit, 10 pa rin ang choices dahil repetition is allowed naman. For example, our first digit is number 8. We can still put number 8 as the second digit kasi allowed yung repetition. Ganun din ang mangyayari sa third to fifth digit. 10 pa rin ang choices natin. With the formula P quantity NR, which is equal to N raised to R, we can have 10 raised to 5 that is equals to 100,000 code. If we're using the mental counting principle, we can write the solution as 10 times 10 times 10 times 10 times 10 na equals sa 100,000 codes. Next problem. How many permutations of 4 letters are there chosen from 26 letters of the alphabet? Ang N natin ay 26 dahil ang pagpipilian natin ay mula A hanggang C. Pero 4 letters lang ang kailangan for the problem kaya R is equals to 4. First up to the 4th letter, 26 ang magiging choices natin because repetition is allowed. By fundamental counting principle, we can write this as 26 times 26 times 26 times 26 that is equal to 456,976 permutations. Kung ang P quantity NR naman ang gagamitin natin, we can have N raised to R is equal to 26 raised to 4 with a product of 456,976 permutations. Dito naman tayo sa pangalawang type ng permutation, which is permutations without repetition na may dalawang conditions, pero dito muna tayo sa permutation of n objects taken n all at a time. These include all n objects and get reduced each time. Gagamitin natin ang formulang P quantity nn is equal to n factorial. N exclamation mark can be read as n factorial. It is a symbol which is used when we wish to multiply consecutive decreasing whole numbers together. In general definition, if n is a positive integer, then n factorial is the product of all integers less than or equal to n. With the formula P quantity nn is equal to npn or simply n factorial, we can have n times quantity n minus 1 times quantity n minus 2 up to quantity n minus r plus 1 or just number 1 as a solution. With this formula, ang black n ay ang total number of objects to choose from at ang red n naman ang total number of objects to arrange in a particular order. Thus, there are n choices for the first position, n minus 1 choices for the second position, and so on. Here are some examples. If n is equal to 5, we can have 5 factorial is equal to 5 times 4 times 3 times 2 times 1 that is equal to 120. Kung ang n ay equal sa 4, 4 factorial is equal to 4 times 3 times 2 times 1 is equal to 24. Kung 3 naman, meron tayong 3 times 2 times 1 is equal to 6. If n is equals to 2, then 2 factorial is equals to 2 times 1 which is equal to 2. If the value of n is 1, we can have 1 factorial is equals to 1. And if n is equals to 0, then 0 factorial is equals to 1. Let's evaluate each expressions that has n factorial. Letter A, 9 factorial. We can have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 362,880. B. 8 factorial over 6 factorial. I-expand muna natin ang numerator at denominator. For 8 factorial, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. At para sa 6 factorial, we have 6 times 5 times 4 times 3 times 2 times 1. As we can see, starting from 6 hanggang 1 ay common na yung numerator at denominator. Kaya ika-cancel natin yun. Ang natira na lamang ay 8 at 7. So by multiplying 8 times 7, we can have 56 as the product. Letter C, 7p7. This can be written as 7 factorial. Kaya 7 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 5040. For the last letter, 5 factorial times 3 factorial. Let's expand the two given. For 5 factorial, we have 5 times 4 times 3 times 2 times 1. And for 3 factorial, we have 3 times 2 times 1. That is equal to 720. Shamil, pwede ka bang magbigay ng mga problems involving permutation without repetition?
Siyempre naman, Joshua. So here's our first example. Ashley has 6 different books. Find the number of orders in which the 6 books can be arranged on a shelf. Now, itry na natin siyang isolve. Let's begin with the given. Our first given is, the number of books is 6. So let's assume that these 6 books are physics, literature, geography, history, chemistry, and mathematics. And then for our second given, the books are arranged 6 at a time. And now, let us proceed to our solution. There are 2 ways we can use for solving this, which is by formula or by fundamental principle of counting or FPC. In by formula, the permutation of 6 objects taken 6 at a time is equals to P quantity 6 and 6, which is equal to 6 factorial, resulting to 720 ways. Ngayon, itry naman natin siya through FPC. But before that, let's take a look first at this shelf. Imagine that in this shelf, there are 6 spots. It is for the first, second, third, fourth, fifth, and sixth spot. The first spot corresponds to N, which is equals to 6, dahil meron pa siyang 6 na librong pagpipilian para sa first spot. So, let's say that nakapili na siya ng book for the first spot, and that is her book in physics. So, for the second spot, which corresponds to quantity N-1, magiging 5 na lang siya. The third spot, which corresponds to quantity N-2, will only have 4 books left na pwede niyang pagpilian. And then, let's say na nakapili ulit siya for the third spot, which is her geography book. So, for the fourth spot, she will only have 3 books left. And after that, the fifth spot will have 2 left, and then for the sixth spot, isa na lang. And with that, pwede na natin silang i-multiply. 6 times 5 times 4 times 3 times 2 times 1 is equals to 720 ways. So, ayun na ang by FPC na method. Now, let's go down to our next problem. There are 4 candidates for a job. The members of the search committee will rank the 4 candidates from the strongest to weakest. How many different outcomes are possible? Let us try to solve this one by FPC or fundamental principle of counting. For the strongest candidate, they will have 4 options. And then for the second strongest candidate, there will be 3 options. For the third strongest candidate, they will have 2 options. And for the weakest candidate, they will have 1 option. Therefore, 4 times 3 times 2 times 1 will be 24. Or we can also solve it by the permutation of 4 objects taken 4 at a time, or 4p4, is equals to 4 factorial, which is equals to 4 times 3 times 2 times 1, resulting to 24 possible outcomes. Ngayon, paano naman if there are fewer slots than all the objects? Here's a sample question for arranging fewer than all the objects. What if there are only 4 slots available on the bookshelf for the 6 books? How is this problem different from the last? Answer: from our previous examples, the total number of all objects and the number of objects taken at a time are the same. However, in this problem, the number of objects taken at a time is fewer than the total number of all objects. So for arranging fewer than all the objects, the permutations of n objects taken r at a time has a formula: p quantity nr is equals to the permutations of n objects taken r at a time is equals to n factorial over quantity n minus r factorial. Now let's move on to the examples for arranging fewer than all the objects. For example number 1, find the number of orders in which the 6 books can be arranged on a shelf with only 4 available slots. For our given, the number of books is 6, and the books are arranged 4 at a time. Therefore, we can have 6p4 is equals to p quantity 6 and 4. Using the formula n factorial over quantity n minus r factorial, we'll end up with 6 factorial over quantity 6 minus 4 factorial, which is equals to 6 factorial over 2 factorial. And then expand 6 factorial to 6 times 5 times 4 times 3 times 2 times 1. And then expand 2 factorial to 2 times 1. So now we have 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. And then let's cancel out the common in the numerator and denominator, which is 1 and 2. And now we have the answer, which is 360 ways. Let's now move on to FPC. Here, we only have 4 available slots in the shelf. Therefore, we'll only have 4 spots for 6 books, which means that only 4 books will be put in the shelf. So for the first spot, there will be 6 choices. And then for the second spot, there will be 5 choices. For the third spot, there will be 4, and then for the fourth spot, there will be 3, which will leave us 6 times 5 times 4 times 3, which is equals to 360 ways also. And for our next problem, how many ways can 5 people sit on a park bench if the bench can only sit 3 people? Here we'll use FPC. So, think of the bench as 3 slots. Therefore, we can have 5, 4, and 3. There are 5 people that can sit in the first slot, leaving 4 remaining people to sit in the second position. And finally, 3 people eligible for the third slot. Thus, there are 5 times 4 times 3 is equals to 60 ways the people can sit. Now let's try it on by formula. 5p3 is equals to p quantity 5 and 3. And again, we'll use the formula n factorial over quantity n minus r factorial, which will leave us with 5 factorial over quantity 5 minus 3 factorial, which is equals to 5 factorial over 2 factorial. And then we'll expand the numerator and denominator. So we will get 5 times 4 times 3 times 2 times 1 over 2 times 1. And then we'll cancel out 2 and 1. So the answer will be 60 ways. And this concludes our presentation.
This is
Group 1.
And thank
Thank you for watching!